Welcome everybody to the first lecture, Databases and Information Systems in the winter semester 25-26. So welcome to the new semester. It's always a bit hard after the summer break, but also a bit exciting. So we have done this many times before, but you always lose your routine over the summer month. And so forgive us if there will be some small mistakes now in the first lecture, but we will get back into routine quickly. So here's overview of today's lecture. So this is the first lecture, so we will talk a bit more than usual about organizational stuff. So what will we do in this course? How is it organized? What's the style? Credits, course systems. And then we also have a little bit of contents, but it will be very light for the beginning. We all need to get into the mood first, so it will be keyword search. You will build a very, very simple search engine, and you will see what that means. And there's also an exercise sheet, which will be to implement a very simple search engine on movies, and you will see what that means in a minute. So let me start with two demos just for motivation what this course will be about. It's databases and information systems. Let me show you two things, two systems. So we are opening the doors because of oxygen. CO2 levels are currently 1,000, but sometimes it gets too loud. People tend to party in the basement, and we have to close the door. So we have a trade-off between oxygen and you hearing me. So it's a graph database, and we will learn later in lecture 6 what a graph database is, but for now let me just show you some example data sets and demos. This is really just to get into the mood. Let me maybe start by showing you one such data set. Who knows Wikidata here in the room? The Wikidata, okay. It's getting more and more people every year. You all know Wikipedia. Wikidata is like the sister project of Wikidata. Let's, for example, look for an entity here. University of Freiburg. Of course, you have a Wikipedia page. And let's maybe look at the Wikipedia page of the University of Freiburg. It's usually one of the first hits. Here it is. Wikipedia, you have one Wikipedia for each language. That's now the English Wikipedia. You have a lot of text, but you also have this structured information here, like what type of university is it, how many, what's the budget, and so on. And this structured information you will have for most universities. And this structured information, here you have it in an info box. Wikidata is all about structured information. And it's not per language, it's for all languages, so everything here does not have a name, but an identifier. Identifiers will be very important already in the first lecture. Whenever you deal with databases search, you will have some form of identifier. So University of Freiburg, it's also here, is Q153987 from now on until the end of time. And then here you see the different names in the different languages, including Bavarian, Arabic, Egyptian, and so on. So it's one page for the whole university. Now we see all the languages. Let's go down a little bit. And now we see like statements or triples, as they are called, like simple sentences. University of Freiburg inception, which means was founded 21st September 1457. And that's Wikidata, so you have all this information, and then you can search it. And let's start with a simple search. That's not what I wanted to do. This is a search engine we are building in our group for searching this data, and let's just, yes, that's my standard query is, I think, this one. Let's start with a first name. Give me a first name, please, that is not too frequent and not too rare. Georg. Georg, that's a nice. And let's just ask all Georgs. So do you want George or Georg? You see there are a lot of variants. You want Georg, right? Let's take this one. Georg, here we have Georg. How many Georgs do we have in Wikidata? A lot, so 9,000 Georgs for which we know the birthplace. So Wikidata knows this person, their first name, where they are born, and also where the birthplace is on a map. We can look at it on a map and we see, I'm surprised, is this right? There are no Georgs outside of Europe. There are a few, okay. So Georg is a very European name used in Scandinavia and so on. Let's look at a few more queries. As I will not explain how this works, just to give you some. Let's look at first exercise sheet, and then many of the exercise sheet will be about movies. This is just, oh wow. I didn't expect that. It's something, maybe, what's happening?
You can change the CS from University of Freiburg to clever, that should work.
Oh, I see. Oh, we changed something recently, so everything we do in this lecture is live. It's not important. So this is actually asking two databases, Wikidata and IMDb. IMDb is a movie database. Thank you. Okay, the error message could have been. So this is now gathering information actually from 3 courses, from Wikidata, from Wikipedia. No, it's not. Wikipedia is not here. Actually, let's see. There should be. Should have prepared this a little better. As I said, we are getting started. One of these queries should be, which one? I think I want to, it doesn't really matter. So for now, I wanted to show you the query where it also shows you the Wikipedia abstract, because we have that for the exercise sheet, but I will show that in a second. What you see here is all the movies known to Wikidata combined with their scores in IMDb. So number of votes, 3 million people have voted for this movie and has a score of 9.3. Let's look at one other data set, OpenStreetMap. Who knows OpenStreetMap? It's also it's all the geodata of the world, amazing data set. Anywhere in the world you zoom in, you will find buildings, the streets, and it's crowdsourced, just like, let's go in Bad Krotzing, you zoom in somewhere here, and all this has been entered by people or uploaded from some public sources. It's quite amazing. We can also ask queries here. Let me show you that. And tell me a country or something big, a big region, maybe not the whole world. And let's look at the street network of that region. You have a big region, country, your favorite country, region. Saxonia, that's too small. But we can, let's try. You mean Sachsen, right? Okay. Let's look at, that second one, right? So let's look at this is now searching for so OpenStreetMap knows, I think, 300 million streets all over the world, and now it's finding all streets in Saxonia. It's taking longer than expected, but it's already done. Now we should see the street network of Saxonia. It's taking more time than usual, not sure why, because it's the beginning of the semester. There we have it. Is that Saxonia? Yeah? I didn't know that shape before. Okay, that's Saxonia, now we know it. So it's actually the street network. Let's zoom in on Dresden here. If we click on this, now we get a piece of street here. So we have seen a lot of searches and so on. Let me show you one other demo. That's a question answering. And I think I will make that quick so that we can move on with the rest. Now you have seen I've asked structured queries, and I haven't talked to you how that works. That's a database query language. We will talk about these things in a lecture 3, 4, 5, and 6. I haven't explained that, but wouldn't it have been nice if you could just ask questions? So let's ask a question here in natural language. Here we have a number of data sets. Let's pick IMDb, and let's ask what are top I wanted top 3 TV series with most episodes. What do you think are the top 3 TV series with most episodes? And I only want well-known ones. So let's say at least 1 million votes on IMDb, and let's just and now what I want the AI in this case to do is figure out the database query itself, and let's just see how that works. It doesn't. What did I do wrong? Okay, this. I should have cancel. Something is. These demos are working really well. So let's try that again. It's okay, I have to type that again. If it doesn't work, we just move on. I'm sorry. With most episodes and at least, so you see I can type it however I want, at least 1 million votes. Okay, now it seems to do something. At least something is turning here. Now it's supposed to, yeah, it's doing something. Okay, we don't know what so now we have an AI, so it's an agentic AI seeing the database for the first time and trying to answer that query from the database. And this is something we will be doing towards the end of the lecture. So I'll search the knowledge graph for, and so first it has a database it hasn't seen ever, sees it for the first time. Now it's trying to figure out how things are called. So it finds there's something called num votes, some table where it says num votes, so it figured that out. Now it's looking for, so I said I want the episodes with most, the series with most episodes. Now it's looking for something, episode count. It finds episode number, which happens to be wrong because that is just the number of the episode, like this is episode number 17 and so on. So now it's saying I'm noticing there isn't a clear num episode, so that was not what it thought it was. And you see, so yeah, very sophisticated stuff. It's trying to figure out, it's finding things which are not the right thing. This is actually the right thing, like the parent title. I have an episode, and this episode is from that TV series. And if we scroll down, let's see, okay, now it finds The Simpsons, and so on. So I think this is enough for demo. And so what did you see? You saw some, all these things there was a lot of data. It was pretty fast. How do you get things to be so fast? That's indexing. That's something we will talk about already today. Ranking is important. So at some point I was searching Saxonia or first names. I got the first names. I got what I wanted first at the top of the list. How do you do that? Then, yeah, databases, how do you store this stuff? How do you query it? That will be a topic. Maybe I make mistakes when I'm typing something. How do you do that? You saw some nice animations. I went to the web. There was a web UI. There was a map visualization. There were dynamic things. This is actually an important part of information systems. So we have 2 lectures only about this, where I will show you how to build this. And then some of the AI stuff, we won't do a lot in this lecture, but we will do some lectures about this. So you will, and actually towards the end you will, I mean, not as sophisticated as what you just have seen, but you will build some pretty cool systems as part of this lecture, which will do things which are quite amazing. So that's the content. And now a bit about the organization and style. So the lectures, as you have realized, because you were here on time, they start a little bit earlier, and then we have time until 5 to 4. And we do that so that we can have a break in between, which will be at around the full hour. There will be 13 lectures altogether. So there will be 4 Tuesdays where there are no lectures. There are these, so the winter break is a bit longer because January 6th there's a holiday, and there's also an additional free slot at November 4. And we do that because we go a little bit over time in the lectures, and to compensate for that, there's 1 week where we have no lecture. And it turns out that it's exactly for every month with teaching, it's exactly 3 lectures. So in every month, October, November, December, January, you will have exactly 3 lectures and 1 week without lecture, which is nice. All lectures are recorded and live streamed via Zoom. So right now we have 53 people via Zoom. If you want, you can also log into Zoom here. Maybe not watching the lecture, you can just watch me here, but there's a chat and you're very welcome to ask questions in the chat, people here in the audience, and please make use of that. I mean, if you watch it here live, make use of the interaction, so don't be shy to ask, you can just talk. Also people in Zoom, you can just talk or you can just write in the chat. And either me or Robin, and let me maybe briefly, Robin, can you briefly stand up maybe? So Robin is the assistant of this course. Thank you, Robin. And he will help with a lot of things, and he will also reply to things in the chat if I don't find the time. Yeah, and you will get to know me and Robin better in the course of this. And there's Frank, who will leave now, our technician, who will make sure that everything works seamlessly. It's quite a sophisticated setup we have here. We're also recording right now with Camtasia, not with Zoom. So whatever you say or do will not be recorded, so don't be shy in that respect either. Everything will be edited afterwards. So at the end of the day, you should also have a properly edited recording of the video. So there's something for everybody, for the people who want to participate via Zoom, who want to come here, who want to watch recording, and you can also do all 3 of them at the same time. And everything will be available on the wiki. Let me show you the wiki page real quick. It's here. You should find that via the campus management system or by just searching on Google. It gives all the information here, also the Zoom link. People in Zoom found it. Also here, before every lecture, it will give you the, so that's useful, I think. Let me just, so the slides, so shortly before the lecture, you also have the slides here, which I think is useful when you're watching it. Maybe you're missing something, you quickly want to go back and check what it was. Also the exercise sheets are here. That's the exercise sheet. I will talk about that in a second. If you have any question at any time, just ask. And let's make this interactive. So we have some party icon here. So exercise sheets. Actually, I say here the exercise sheets are an important part of the course. I would say they are the most important part of the course. You only learn something if you apply it. There's 1 sheet per lecture except the last, altogether 12. Deadline is always 2 hours before the lecture starts, so that we have a chance to read your feedback. Unlike in the beginner courses, which we also teach, like programming in C++ and algorithms and data structures, exercises are voluntary, which means you don't need 50% of the points. You can do them or not do them. More information about that soon. You can work in groups if you like. If you work in groups, because you will get feedback, only one of you should commit. Yeah, we have 4 tutors. We don't want 2 tutors correct or give feedback on the same thing. So still, you shouldn't plagiarize, and there are rules on that. I will show. It doesn't make sense if you don't need points, but human beings are known to do things which don't make sense. So please don't do it. It's meaningless, and we have 4 people who who want to help you, and their energy should be conserved. So there will be so this is the only slot in the week where you will see someone live and where it's interactive. Everything else is online. There are always a few people that said, wouldn't it be nice to have a live tutorial? We can tell you we have tried this in 100 variants already. Nobody comes to these live tutorials, and the people who come only listen. It doesn't make sense. So, there will also be no weekly Q&A. We have tried that. It's the same thing. So believe us, it doesn't work. So this is this one place, and that's enough, 2 hours per week, where you have the chance to interact and ask questions. If you submit an exercise sheet, which you don't have to, you will receive feedback on it within 3 days by one of our tutors. This is very important. Please listen. Please pay attention to this. If you want feedback, you have to write it in your... There's always a file which you commit along with each exercise sheet. You will commit online. I will talk about that towards the end. And you have to write, please give me feedback. And you also have to say what feedback you want. It's really important to conserve energies of the tutors, because people are different. Some people don't want feedback, they just want, or maybe they say, just have a quick look and tell me whether it's okay. Other people say, oh, here I had a problem, can you please have a look, can you help me? Different people want very different kinds of feedback, also different amounts of feedback. So just tell us in this file exactly what feedback you want or not want, and then your tutor will be happy to give it to you. And that worked really well in the last years. There's also a forum, and there's for all kinds of questions. And so once you have submitted your first sheet, which will be in a week, you will be assigned a tutor for the rest. So there will be one tutor assigned to you if you want, and you can make individual appointments with them. If you need a real person to talk to, some people want that, you can also have that. So as you can see, there are a lot of modes we have prepared to support you, so in the hope that one of them will be suitable to you. Style of the lectures, you are already experiencing it right now. So I will provide motivation, hopefully, definitions, examples, live code. We will do a lot of live coding. It's always a lot of fun. So the emphasis is on getting you started, not explaining every little detail to you. Yeah, working the only way. Yeah, we are hardwired, evolutionary as humans, to only learn if you do something yourself. That's something I was saying. Greeting our first semesters on Friday, so the people who are just starting their new studies. And I always have one slide where I emphasize this: the most important thing about learning is doing it yourself. There's this very strong tendency, and it's of course exacerbated by social media, to just listen to stuff, right? You listen to an educational video and it's all so nice and entertaining, and you listen to it, it's well done, say, yeah, I understood that, video is over, went into one ear, out of the others, you don't remember anything. You have to apply yourself, you have to do it so that it sticks. It's just no way, you can't learn otherwise. So exercise, you have to do the exercises if you want to learn something. There's always one topic per lecture, so the lectures are self-contained in that way, and we provide everything you need to understand the lecture and also to do the sheet. There are some literature pointers at the end, but it shouldn't be necessary to go to other material. Of course, you're welcome to, but you don't have to. We are very nice. If you are nice, that's very important. So we both have a role in this course. Maybe it will become clearer in the course of the lectures what I mean by that. So we invest a lot of work in this. We want that you learn something. Your part of the work is to learn something and do the work. So learning and paying attention. So one example of this not being the right way is sometimes people ask questions on the forum about something which is written on slide 2. So yeah, of course you should first look at the slides and go to the lectures, and then if something is not clear, you should ask a question. So yeah, we both have our roles and we both should do our work, and then this will work out very nicely. So what should you learn in this course? So 2 types of understanding, that's also an important slide. So There's the theoretical part. There will be concepts which you will hear for the first time, and you should understand them in depth. But then you should also apply it in practice. And this, for this course and our group in particular, it's very, very important. So at the university, there is the prejudice, and it's actually true, that you learn a lot of theory, but not how you apply it. I think it's true for many courses and also other areas. And then in other places, you often learn how to do things, but you don't really learn why you do it that way, or you don't really understand it. So in this course, both are equally important. That's really, really the essence of this course. So both are important. You will learn about both, the theory and applying it, and the exam will also test both. In particular, you will also write code in the exam. More about that later. There will be master solutions for everything, but again, it absolutely doesn't make sense to read the master solution if you haven't done the sheet. Only use them if you have worked on the sheet to check if what you did was made sense. But if you apply it yourself, you will find that out yourself. SVN, I will talk about that later, so they will also be linked on the wiki. Important, please don't pass them on. So it's really nice of us to provide master solutions, but they are not for putting them on the web. So they are not for public use in any way. They are just for your personal use now and in the future. Please take that seriously. Yeah, don't pass them on to others or let others access them. So a little bit about the credits. So you get six ECTS, like for most of the courses here at the technical faculty. So this is, that's 180 working hours over the whole semester. So there are 30 hours of lectures. So just if you come here, then there are the exercise sheets. That should be where you spend most of your work on and exam preparation. Here are the three options. I mean, you have the liberty in this course to do 0 hours on the exercise sheet if you want, up to you. Maybe appropriate for some people, probably not for most. 8 hours on the exercise sheet. If you do that, I mean, it should be a lot of fun to work on the sheet. And then you don't have to do anything for the exam anymore. You're well prepared for the exam. There's option C. We know that there are always some people who miss a lot of prerequisites. Yeah, there will be some math which is hard, which you didn't really understand in earlier semesters, or there's just, we also will do programming. Maybe people are completely out of practice or never really learned it properly. So we know that, that's what's written here. You're welcome to do this course as well, so there's no strict precondition, but then just be prepared that it will be a lot more work for you, right? If something is missing, you haven't learned it in earlier semesters, you are learning it now on the side as part of this course, that is fine, but then of course it will be more work for you, and please don't blame us for it. And I see some questions in the chat. Why were we able to sign up for a tutor group on HisIn1? Yeah, this was because it's just there on HisIn1. It's not, it doesn't harm, but it was also wasn't important. So sorry if you wasted a few minutes there. There is nothing on. So tutor groups on HisIn1 don't mean anything. I hope I have answered that. Is degree bachelor and degree program informatic correct when registering in Daphne if we are in our 3rd semester? I don't think I understand that question. Do you understand it?
When signing up for Daphne, we have to enter our degree and our...
Oh, yeah. Yeah, both are fine. Both are fine. Otto sent me a direct message. I'm not sure why. What are the prerequisites? I think prerequisites, okay. Yeah, here I just said if you miss them, prerequisites are you should have learned some programming, preferably the introduction to programming and the more advanced programming, but introduction is also fine, that would be good, and the basic math, which you learn in the 1st semester. because we will use some math. Should we sign out of it, or does it not matter? HIS-in-1 does not matter regarding the tutorials. You can do what you want there, it's not important. Okay, let me move on. And now it's 56 people on Zoom. Okay, wasn't it 59? Studienleistung. So there are two parts. There's the exam, of course, I will get to that. And there's also this thing called Studienleistung, which is stuff of the course that's not graded. And for this course, you get the Studienleistung basically for free. Almost nothing is really for free. You have to register on Daphne and register for the exam. So that's a very low bar, but you have to do that. So this is not yet urgent. There's a deadline. I looked it up for you. It's 11th of January. And I think it's the first time I wrote 2026, which will be yeah. Nevertheless, you do get points. Let me just explain that. So if you submit something and you say, I want feedback, we will give you points, but these points will not be counted. They are not important for getting the Studienleistung or anything. It's just for you to get feedback, right? You do something, now you get points, so you just get a feeling for how well you did. So we have 4 tutors. If now all of you decide to submit all of your exercise sheets, we have a problem. It doesn't happen usually, so I think we are fine. 4 tutors should be enough, but let's just see. So if we are swamped with submissions, then we have to see how we organize that, but usually it self-organizes itself very well. There will be an exam in the end, of course. It's a written exam. Date is not yet fixed, I think, and it's always the same, by the way, on the wiki, if you want to look at there. So we are very transparent with everything. In particular, you find all the exams from previous semesters here. I know that Fachschaft has a Klausur exam database. You don't have to go there because it's just all here, even with master solutions. But don't look at the master solution before you have tried them yourself. So it's all here, even the previous exams, and they are always of a very similar format. The tasks are not the same, they are different from year to year. But the format is very similar. You can get 100 points, half of the points to pass. And that's important. The exam will test all of the following 3. So basic understanding is not enough to pass the exam, right? You need to understand the basics, you need to have a little deeper understanding, and you also need to know how to apply it. And all 3, there are always questions about all 3 parts. If you want, have a look at some of the early exams to see what I mean by that. Points are important for ego and rivalries. Yes. Oh, Robin said that, exactly. So maybe you're competing with one of your colleagues, and then that's fine, whatever motivates you. Yes. Are we allowed to write answers in German? And okay, yes, you are allowed to write in German also for the exam, but our language of communication will be strictly English. So there will not be a version of the exam in German, but if you want to write in German, French, I'm not sure, but yeah, German and English are fine. So you can communicate in English or German, we will communicate in English. So that's it for the organizational part. It's 20 to 3. I think that's a good timing. Any questions about the organizational part, style, anything regarding the overall thing before we now go into our first topic very lightly? So, yeah, I understand you're still all a little bit shy, but really, when you come here, and there are always a decent number of people who come here, which is nice, use the opportunity to interact. It's something one also has to learn and should learn, that while listening, also thinking, interacting, asking questions, and not always, there are always 1 or 2 people who do that anyway, but also the other people try to overcome your inner barriers and just get yourself to ask questions. It helps learning and it's a good skill. And you have a question or comment?
Yeah, since I've already heard like a database lecture in like my university where I did my bachelor's, can you tell me how much of the lecture will be about like relational database?
How much will be about relational databases? You can actually go back. So we gave this course 2 years ago because I was on a sabbatical last year, and it will be not the same but similar to this one. So let's look at this a little bit. So this is the lectures from 2 years ago, not same but similar. First 2 lectures, it's called databases and information systems. So information systems are much more than databases, right? It's not a pure database lecture. First 2 lectures will be about search engines because that's a very easy start and it's one way, what you type in a few words, you get hits. Then 3 lectures about classic databases, no more, just the basic. 1 lecture about knowledge graphs, which is databases plus. Then a little bit about making typing errors. Then 2 lectures about web applications, as I've said, an important part to actually build something. And it's very nice, and you should learn that. And then 3 more lectures. This will be different from 2 years ago about AI stuff. Because, these agentic systems, you all know ChatGPT, these are also information systems very much, right? So you should really get a potpourri and overview of everything. And databases are there, but just 3 lectures. So if you have done all the exercises, you will also understand the questions in English during the exam. Oh yes, you will learn enough English. And anyway, I think to study, it's one of the prerequisites that you need to have a certain knowledge of English. Any other questions for now? Because before we just move on to our first topic. So let's move on, and you can ask any time, but also later. So keyword search. So exercise sheet will be to build a very simple search engine. Search engine is what you all know from Google. You just type in, this is how you did search until recently, and sometimes you still do. You type a few keywords, you get a result. So you have a lot of text documents. And let me start right away by showing you the data set from the exercise sheet, which will be movie descriptions. And here it is. So it's movie descriptions. Let me maybe make that larger for now. And let me put line numbers here. So, and they are ordered by IMDb votes or score, I'm not sure, it doesn't matter. So you have the most popular movie in the beginning. So here you have the all-time number 1 of, who knows, The Shawshank Redemption, this movie, you should watch it. All these movies at the top are, that's also an important part of the course, to watch movies. I think everybody should have watched the top 10 by the end, and there will be questions, of course, in the exam. So here you have the title, that's a tabulator here, and then you have the just text from Wikipedia. And let me just show it by just showing you the first line of this file. There you have it. So that's the title. That's just the first part of the Wikipedia article, which is essentially the plot, and a little bit about the history of the movie. That's the number of votes on IMDb. That's the rating, and that's a number of Wikipedia articles essentially about it. So just some popularity measures. And let's go back to here. So let's go to the end of this. So you see it's 126,648 movies. So quite a lot. And we want to search in the descriptions. So that's what we want to do. And so keyword query would be something like Spielberg dinosaurs. What would you expect to be a hit? Jurassic Park, yeah, exactly. So any number of keywords for the exercise sheet, that's a 2 keyword query. and you want to return documents. So for the exercise sheet, very simple, just return 3 documents. Ranking-wise, you can just return them, so you can make use of the order here. We already ordered them by popularity. So if you just return the 3 which are first in the file, they are also the most popular. And then lecture 2 will be about ranking. Yeah, whenever you have a lot of things and you return them, you want to return the most relevance first. But for this first exercise sheet, ranking is not important. So here's a naive solution. You can just use like Linux grep. And let me just do that. We could just, for example, let's just do, I could do grep Spielberg. So Steven Spiel, I just grep and let me choose -I, which means case insensitive. Yeah, and now I get some, why do I get interstellar? Probably is mentioned somewhere there. Let's just, so, and let's now head -1. So that's the first hit here. Yeah, so you already see some of the pitfalls of the screenplay in a script had developed and was originally set to be directed by Steven Spielberg, right? So he was set to be the director of Interstellar, but he wasn't. So just because a document is a hit for Spielberg doesn't mean it was directed by him. So you get the idea. So we have, I can just do grep and I get some results. Grep will just go through the text. And it's actually pretty fast, 1 gigabyte per second. Machines are not a bad approach. Let's assume that you do that for the whole web. It's a secret how much pages are indexed by Google. Estimate is about 1 trillion. Trillion is 1,000 billion. 1 million million. It's a lot. Actually, I looked up the best sources. There was a trial, USA versus Google, about antitrust trial. And as a part of that trial, which there were public transcripts, and one of the executives had to reveal how many pages were in their index, and it was 500 billion 5 years ago. So I just extrapolated from that to trillion. That's just, if you have an average of 10,000 characters per web page of text, I mean, there's a lot of stuff on pages that's not text, images, that's 10 petabytes. Which is actually not that much. It's amazing. So the whole indexed web is just 10 petabytes, 10,000 terabytes, 10 million gigabytes. I mean, a few terabytes you can have on your notebook. And this is just a side remark, which you will understand towards the end of the lecture. So now let's assume you don't have a toy collection, but a little bit larger one. And this one is already of decent size. How do you do it? You use an inverted index, and that's the one conceptual thing you will learn today. Very simple, but very important. You need this everywhere. And this is just, for every word in your collection, you pre-compute a list of documents containing it. So this says Steven Spielberg, so let's just give each, and let's actually just do that here. Let me do the following. Let me do NL, and just to make it very clear NL will just prefix everything by a line number. So now I have 1, 2, 3, 4, 5 here. And now let me grab again Spielberg. And let's look at that. And now I get, so Spielberg is contained in movie number 6, 22, 24, 53, 62, which are actually the numbers here. That's called an inverted list. It's just, why is it called inverted list? Because the way this collection is given is you're given movies, and for every movie you're given the words, or for every text you're given the words in the text. And inverted is for every word now I have the list of documents containing the text. So normal order is for every text the words in it, and here it's for every word the text containing it. But not the text, but their IDs. line numbers in this case. Here, dinosaurs, we do the same thing. We get this list, and that's an inverted index. And we will actually write code for it in a minute. These lists are called inverted lists. Very simple, very important principle. And now the question is, what do you do if dinosaurs occurs 3 times in a document? So for exercise sheet 1, it should just be there once. Yeah. So if it occurs 3 times, still you only want 62 here once. One thing you could do, you could also store the count like a pair 62,3, meaning dinosaurs occurs 3 times in document 62, and we will talk more about that in the next lecture. So now you have these inverted lists. How do you process a query? Well, let's take the simplest case. If you have just one keyword, Spielberg, you have already computed your query, right? You have this list pre-computed. That's called, it's your index. So if you pre-compute something for search, it's called an index, which means you just look it up. You have that list stored somewhere and you just say, oh, you want Spielberg, it's document 62224. It's very fast. And that's the reason, I mean, that's in principle how search engines like Google work. That's why it's so fast. You type a keyword, you type 2 keywords. It just takes these lists and does something with them. And with one keyword, it's super fast. So it's very simple. 2 keywords, a bit more complicated. So now we will learn the first simple algorithm of this lecture. So how do we do that? And now I will show you an algorithm which you should implement for the lecture. So now, let me pick a nice color here. So that's let me call that list L1 and that list L2. And what do I have conceptually now? Conceptually, I have 2 lists of sorted integers. And they are sorted, that's important, they are both in ascending order. And that allows me to use an efficient algorithm, which I will now explain by example, and you have to implement it. We will do that a lot. So now I want the intersection of L1 and L2, which means all doc IDs which occur in both. How do I do that? So I start with a pointer here and here. Now I look at the 2, it's 6 and 62. They are not the same, which means I haven't found a match yet. I'm looking for numbers, IDs. It's IDs of text records which occur in both. They are not equal. Now I advance in one of the lists. I advance in the list with the smaller number. So I will just play this algorithm for you. That's smaller. Now I have 22. Now I look at 22 and 62, not the same. So again, I advance here. So I advance here, I advance here. Now it could be a number larger than 62, but it's actually 62. So now I have a match and I write it to the result. And now I advance in both lists. So now 102, 194, I advance here, and I found another match. So maybe this was a match here. And maybe you can see how that works. So here it happens to be the case that Spielberg is contained in a lot more documents, or at least documents with lower number than dinosaurs, but that's just for this particular example. So here I have 194, and so on. These lists can be very long, and now I move on here and here. And you have to figure out the edge cases and how to actually implement this. But I think the principle is clear. What's also clear from this example is in every list you only advance in one direction, right? You always only go to the right, never to the left, which means in the end you have made one pass over this list and one pass over this list, which means it's linear in the side of these 2 lists, which is very fast, even if the lists are large. So this was intersection, only finding documents that are contained in both lists. In the next lecture, we will also do merging. You also want the numbers which are just occur in one of the lists, but you also, it's called merging 2 sorted lists. You want the sorted union. We will do that in the next lecture. Any question about list intersection and this algorithm? Yes, please?
Why do you go through both of the lists? Shouldn't it be enough to go to the end of one of the lists and stop?
So why do we go through both of the lists? Shouldn't it be enough to go through one of the lists? Can you explain what you mean by going through one of the lists?
Since the lists are sorted by
Yeah.
number, if you reach the end of one of the lists, there shouldn't be another match, even if you go through the end.
Oh, you mean when you have reached the end of one list, you don't have to go exactly. Exactly. That would be an optimization, and you're welcome to implement it for the sheet. If you have reached the end of one list, which actually can happen, maybe it's very short because it's a very rare word, you don't have to bother about the other list anymore. If you do intersection. Very good observation, and you're welcome to implement that. Actually, list intersection, there's a lot of theoretical research about doing that more efficiently than this. And yeah, just imagine you have a very small list here, we have a large list here. Can you skip large portions of that list? If the exercise sheet is boring for you in its simple form, feel free to think of fancy optimizations. But this simple linear time algorithm is fine for now. But there's actually a lot of interesting stuff you can do. So for the exercise sheet, you should also be able to do more than 2 keywords. Then a number of questions arise. First is, how do you generalize this algorithm? And actually you can generalize it, like now you have 3, 4, 5 lists. You can do the same thing. You have a pointer for each list. If it's k lists, now you have always k things which you look at the same time. And you have to find the smallest one. You can use a priority queue for that. If you want to do that, you can. For the exercise sheet, you can just do it very simple. We're just getting started. You just pick 2 of them, you compute this intersection, then you intersect that with the next one, and so on. So for the exercise sheet, just do pairwise intersection, just to keep it simple. But if you want to do more complicated stuff, you can. So this here would be the variant with all k at the same time using a priority queue. It's not so hard. If you want to think about it, it's totally optional. And also, if you do the pairwise thing, in which order do you do it? You start with the smaller lists. Always good if one of the lists is small. You don't have to do these, but you can. Yes, please? What language should you be using? Very good question. I think I would have come to that, but let's just do it now. So there's this exercise sheet, and at the top of the exercise sheet, things are in red and bold, which means you should read them. And carefully, here it says carefully and completely. Read carefully and completely, and what that means is that you should read it carefully and completely. I hope it's clear. So let's click on that. And this is not something we will do now, but you should do it afterwards, and everybody should do it, even if you don't do the exercise sheet, because it will explain a number of basic things. And it would be boring to go through them now, which is why we have written them up. And the first thing is about the programming language. That's your question. So in the past, we have allowed many languages, but anybody used Python anyway. We have also switched to using it in the lecture. I mean, we are proficient with a number of languages, but for teaching, it's just nice and fast. Of course, you can't show some efficiency things, but that's fine. So it will be Python, at least version 3.10. Standard version now is 3.12. So Python. And other languages are not allowed because they would just make too much work. Does it answer your question? So just Python in the lecture. And you have a question? No question. You were just exercise, yes?
Can you use any version of Python? Because I think 3.13 introduced like changing behavior.
Yeah. Python has this annoying property of always breaking everything. So Python actually has some, it's nice, but also pretty terrible in other respects. 3.12 is not fine, 3.13. Robin, do we want to allow 3.13?
We can allow it, I think, but I'm not sure if I can update the image.
Yeah, So if you are a very big fan, let's try. But if it breaks, Python has this annoying property of just breaking everything with new versions. They just don't care. Other languages take a lot of care to not be backward compatible. Python just doesn't care. But so yeah, maybe don't unless you absolutely exist and you are extremely... Oh, 3.14 just got released. Oh my. Python, okay, Py. So let's go on. And we will we will write code in a minute after the break. A few more things. So for that we have to break text into words. Let's go here, right? So I have to break that into words, and we ignore case, so we will make saving with lowercase s here. How do you break text into words? That looks very simple, right? You just, everything you just, until the next space, and then you lowercase it. And actually that's exactly how we will do it after the break when we live code. In reality, it's a little more complicated. Here are some examples. That's Japanese. Who can read Japanese in the room? It's a haiku, a famous one. Nobody can read Japanese. That's a pity. That's also something you should have learned by the end of this course, of course. There are always exam questions about that. Here's one, that's a typical German word, Semestereröffnungsparty, Organisationskomiteevorsitzende, Finnish. It's also famous for such words. Do you want to index these whole words, or rather the individual words? Yeah, these concatenations. So splitting by space does not really help you here. Then you have languages with funny characters. So that's österreichische Gemüsebrühe mit Knödeln. And it's doing funny stuff here because something went wrong with the umlauts, the special characters, and we have a lecture about that. This is something you should understand by the end of the lecture. And yeah, if you just break by non-typical characters, you will just have the word gem here and zibr here, and and this actually happens a lot. So tokenization, if you do it properly, is really, it's hard. But for the exercise sheet, we do everything in the most simplest way. And we will learn about that, UTF-8, proper encoding of all characters of the word. It's actually an exciting topic. Lecture 7. So, this is something we will do after the break. Any urgent question before the break? CO2 level are actually perfect, below 1,000, because you opened the window. That was a good move. Any question before the break? Otherwise, we have 10-minute break, and then, so enjoy the break. So, second part, and now we do some live coding. So now we want to, and let's see. I need your help, because I'm out of practice with Python. I usually code C++. So now we just want to, what does it say here? We want to construct an inverted index. And it says something here on the slides. I will not explain it now. I will explain it while we are doing it. So let's just start. So what I want is I want to read a file like this one, like we have seen here. And I think I want to, I need the example file. Is this already in the templates, Robin? The example TSV, or should I copy it? Should be. So let's do an update. Okay, my password. Okay, that was not working out. 1, 2, 3, 4. Merge the directories. Tree conflicts. Oh my. So now I have to, the joys of programming, I have to find my example file. Internal code lecture 1. Yes, here it is. So that's a very simple, it's the same structure, so it's just doc1, doc2, doc3. We call the text records documents here. It's really just short things, a movie, a film, movie. And also here we have votes and a score and something, but we don't need that. And now we want to build an inverted index for this. So inverted index means for movie, it will be in document 1 and 3, so the list should be 1, 3. And actually here, if it occurs twice in document 1, I will just have 1, 1. I will ignore that for now. You should probably, you should do it correctly in the, and now I have, okay, I wanted to prepare the unit test, but I haven't done that. Let's just do that together. Inverted index.py, we will just write a Python program from scratch. Here we have the copyright notice, and let's just start. And you have to help me. So class, we write an inverted index. Okay, so that's a very simple inverted index as explained in lecture 1. And you have to pay attention and tell me when I make a mistake right away. And so we start with a constructor. How do we init? And its object orientation is a bit weird in Python. You have this self thing start with an empty inverted index. And now how do the lists look like? So we have inverted lists. Now we have to think about the data structures and what we want.
Misspelled self.
I misspelled. Which line? Self. Okay, that's, thank you. Oh my. So inverted lists. And what do we want? So we have one list for each word. So it's a map from, let's use a dictionary from, so we have something for each word, and for each word we have a list of integers. So yeah, these are called type-ins in Python. Yeah, so for each word, which is a string, I have a list of integers, and you tell me when I'm doing something stupid, and I start with the empty thing. Okay. And now I want something to build an inverted index from a file. So what I have here is the object self itself, and I have a file name. File name, which is a string, and this is just build inverted index from the given file. Use the simple tokenization explained in the lecture, and we will, let's just start writing code. And I will do a lot of mistakes when writing code, and we will learn something from this. So let's just, let's open the file name for reading, we don't need anything else, as file. So let's iterate over the for line in file. Can I do that in Python? Can I do that in Python? How?
Lines, I think.
And where do I get the lines from?
File of big lines or something.
Should just work like that. I don't think
Really?
Let's see whether it works. So let's just have we are all getting used to it a little bit. So let's write a main program here. This is so weird. Python does this. I mean, this I can't tell you. So let's just start with an inverted. Let's do some argument passing. This is something you will need for. We are just getting warmed up, so it's just finger exercises. Argparse. So parser is, how does this work? Argument parser. What do we need? Help. Okay, build an inverted index from a text file. Let's add an argument. And we want, what do we want? We want the file name, right? That's how we want to call it. Let's have some help text. And that is the input file. And now args is parser dot, what's the syntax? Oh, sorry. Args. Okay, there it was. Okay, and now, so let's write a comment here at the top. Sorry for the typing mistakes. Something is wrong here. Now it works again. So parse the command line arguments. I'm getting command line arguments. And I think we have already done half of the work. It's always the boring work in the beginning. In the next lectures, I will prepare the boring work. But for now, we just write it from scratch to learn some things. Here I used rough. Rough is something for auto-formatting. I think that's written somewhere on the sheet or in the rules. If not, we will add it. You just, to follow a consistent style, we're using rough format, rough check fixes, so that I have consistent indenting lines and everything. So here it added 2 lines and so on. Okay, let's just call parse build inverted index for the input file, for the given input file. How do we do that? If you have a Python question, just ask. So the inverted index is here. We just do the inverted index. And now we call build from file above with our file name. And for now, our parsing just printed the lines of the file. Let's just see if that works. So that's our first. Will it compile? Did I make a mistake? So it's our joint responsibility that this compiles. Let's just check Python 3 inverted index. Now it should tell me that it wants a file name. Yes, and now I will just say example TSV. Okay, that worked. It added a new line because print adds a new line and the lines also have a new line. Okay, so we can do for line in file. And that's also something I recommend in the beginning. When you write something bigger, do it incrementally, right? Do something simple at first just to see whether it works and then incrementally go from there. Okay, so we need to count the line numbers, so let me just call it text records, not documents. It's not really documents here. So now I'm in the first line, so that's record ID plus equal 1, so it will be 1, 2, 3. We just start from 1. We could also start from 0, but let's start from 1. And now I want to tokenize the lines. And how do I do that? That's the... So I think there is find all. RE is regular expressions in Python. Let me just add it here. Import regular expression. And there's a function actually in Python, which we will be happy to use here. Find all maximal. So R, it's a regular expression. Let's just find all maximal sequences of the normal English characters. So capital letters and small letters and plus, which means just one or more of them, and this should just find all of them.
It's written
And
with a lowercase a. It's written with a lowercase a.
With a lowercase a, and like that, or okay, we will. And now we have to say in what we want to find them, and for that I actually need to. So our line has this format. It's the title. We just want to this stuff, right? So I think before that we should first. So we have a title, we have a description, and we have the rest, which we don't care about, and let's just split that by tabulator. Yeah, so this is the stuff in the beginning. It will take more time, so we're just interested in the first two, and the rest is just, that's just an unnamed variable here. So this should be in the description, okay? So now let's just, for word in words, and let's just print it for now to just see if it works. So F, what do I want to print? I want to print the word and maybe the record ID. And let's just see whether it makes sense for our little example program. So now I would expect that it shows A1, movie 1, movie 1, A2, film 2, movie 3. If I didn't make a mistake. Okay, that seems to have worked. So now we are almost there. So now we just have to add it to our inverted list, right? So here we have the word one. So we have to take the inverted list for we lowercase it. First, if, and maybe we do the lowercasing here. Yeah, where do we do the lowercasing? Here, there. Doesn't really, we could already do it here, right? Then we don't. How do I, what's lowercasing in Python? Who knows it? Lower? Lower, okay. So, if the word is not yet in our inverted index, if word not in self-inverted lists, it's a dictionary, right? Then I add it first, so self-inverted lists, and I made a mistake here. Inverted lists, word, and in the beginning it's empty, it's a list of integers, sorted integers is empty here. I've added that here. Now, after this if, either it already existed before, I just created it as empty, so in both cases I can just append word inverted lists, word dot append, and I just embed the record ID. And just note, because I'm going through the documents in order, that naturally I will get my inverted lists in order of ascending document IDs, right? So by this line 37, here I meet for the first time, so I will create the inverted list for it will be empty. I append 1, here I see it again in the second document, I will append 2, because I'm going through the documents in order, my inverted lists will be in order also. And I think that was already it. Let's maybe do a unit test here, doc test they are called. So let me do II equals, let me do that here, inverted index. Let's build from file here, and the file is example TSV, so that's part of our tests. And now we can, so that's called a doc test. So in the documentation I write a simple test, which Python can automatically check. So inverted lists of, let's just see what the invert, so how should the inverted lists look like? This will now be a dictionary. How does a dictionary look like? So what would I, let's just open the example TSV above here, and let's just make this a little smaller. So that's our, above I have example TSV, it's just 3 documents. So what do we expect here? And actually, let me maybe just, I think I want them, I'm actually not sure, the Python dictionary, will it be ordered by default by the words in, I think it is starting from, in earlier versions it isn't, so I would expect that the first inverted list is and what do I have here in the, so what's the inverted list for given the doc above? So it's 1, 2, 3 line numbers are there. Yes, you can just say it. 1, 2, yes. What will be the next word? What will be, Movie, yeah. That's the next word here. What's the inverted list in the way we implemented it? 1, 3. Yeah, 1, 1, 3. We didn't do anything about duplicates. We just added again. In the exercise sheet, you have to do it. So 1, 1, 3. What's the next one? I mistyped again. The next new again. Film will be the next one I see. What's the inverted list? 2. Just 2. And the next. And then that's it, right? Let's just see. So now I have a unit test. How do I... So if I now ask Python, please check whether this test does as what it should do, I can just do the following. There's a module doc test, so I don't have to run it with any, and you should always do that for all exercise sheets. There will be doc tests either by us or you write them. Okay, expected got. So, that's what will happen in the lecture many times, also for you. What did we do wrong?
Can you type this?
It's not called examples, it's called example. So in line 27,
Yes. Example. That's a good theory. Let's test it. Yeah, and it said here, file not found. So, okay, that looks good. What's wrong now? Yeah, just spaces, right? I mean, essentially it said it expected this, it got this, was correct, but just if you, a dictionary, if you just print it in the standard way, it doesn't have funny spaces here. So actually, yeah, pretty good. We wrote a doc test, we wrote an inverted index, it works. So now it just works. So we have written, well, we have built our first inverted index. And now, let's do one more thing. Now let's apply it to the real thing, and let's just look at the length of the inverted and show the length of each inverted list. Yeah, so let's just do the following. So after we have, so now I want to for word in, I just want to iterate in II inverted lists. Do the following, I just want to print, let's again do a format string, just want to print the word, a tabulator, and the length of the inverted list. And there's still a small mistake here, where is it? I think this should be items. If I wanted things from the hash, from the dictionary as pairs, it's a dictionary from strings to list of integers, and I want pairs of the word and the inverted list, and this should just print. Yeah, let's just do that for the example. Yeah, now I should, yeah, let's just look at the example again. It should print all the words that occurred in the order how I encountered them first, and that's just the length. And the length of an inverted list is just how many occurrences there are of that word, right? 2 means there is a in lower or uppercase twice in my whole text. Movie is there 3 times, so that's the length of the inverted list. Movie, movie, movie. Film is there once. And now the nice thing about programming and computer science is that if it works for 3 documents, it also works for 126,600 something documents. So we can just run the same program here. And now it will, let me just show the first head, 30 lines of output, and it takes a little longer. Yeah, the is the first. So the occurs in our collection 573,587 times. Shawshank just 5 times. It's a rare word. And broken pipe is just because I said stop after 30. Let's maybe just sort this. So this is now word and count. Let's sort by frequency. How do I sort by frequency? There's a command for that. Let's, what's the command? I think tabulator minus K2 by the second field. If I separate by tabulator, numeric order, largest first. So you should also learn a little shell magic. So now I just sort them by the second number in, okay. So now we have the most frequent words from, so we have already written a pretty interesting program. Most frequent word is the, maybe not that surprising, followed by and, followed by film. What a surprise. Directed is also pretty frequent. So you see a lot of funny words. These are called stop words. They are not really useful for search. And it is something we will talk about in later lectures, in the next one actually. And typical movie words, released, written, starring, drama, and so on, right? And if we go further down the list, maybe we can do that. Animated, screen, following, selected, adapted, yeah. That's our inverted index. Now we can go, do we need to clear inverted lists before populating it? What do you mean clear? Haven't we cleared it here in the beginning? We have, right? Up here we said start with an inverted, with an empty one. If that's what the question was.
I think you can just call build from file multiple times and then you would override the old.
Oh, I see. If you yeah, exactly. If you would call build from file again, you would append to the existing one, which is questionable.
In practice, you will only call it once.
Yeah, yeah. Yeah, so we are not writing a full system yet, but it's a valid question. So here's, yeah, this is something I keep. These are annotations, which from my preparation. We're almost at the last slide, by the way. So we do have some time for, yeah, I didn't want that here. Zipf's law. So let's learn one more thing. Let Fn and understand Zipf's law. So for a particular collection, I can just look at the words, order them by frequency. Frequency is the number we have just seen. How often do they occur? And now what we see here, let me just do it again with the less thing. Let me do less minus capital N. Minus capital N will just prepend the line number. So what this will show me now is, yeah, so the most frequent word, one is the, and this is the frequency. So in this terminology, capital F1 will be this number, 573587. Capital F2, the frequency of the second most frequent word, is 365345, and so on. And you see these numbers, they are of course going down, but now the question is, how do they go down? Which does this follow some law, some curve? And the funny thing is that it does independent of what you input. Now it's movies, take any other text collection, this will always have a very characteristic way of going down, and we will now have a look at that. And yeah, let's just do that. So what we do is, let me just take the second column, I'm not interested in the word, and let me just prefix it with a line number, and let's look at that again. Yeah, so if you're unfamiliar with these shell commands, you can look it up in the recording and then search a little bit yourself. So now I really just have, right, first number, most frequent, this is the frequency, it was the, but I don't care. Second most frequent has this frequency. Let's just write it to a file, and let's call it word frequencies. Frequencies.tsv, it's tab separated, so yeah. And actually for the NL, I didn't want the number format, number width. I don't want the, let me do minus W0, I think then it will not, okay. Result out of range, let me do 1. I don't want this to be prefixed by spaces, let's just look at it. Yeah, that's nice now. So now I have just Frequency 1 to most frequent, second most frequent, tabulator number. That's what I want. Now let's just plot this. There's a program, GNU plot there. Any number of programs who will I just want to plot this on the x-axis, this on the y-axis. What curve will we get? It will be a falling curve. How will it be falling? Think about it. Let's do it with a GNU plot. That's simple enough. And let's just do plot, and then you can just give it the file. If I give it a file with 2 columns, it will do the obvious thing. And there it was. Did you see it? It was there for 10 milliseconds again. Okay, we need to add something like pause indefinitely, maybe for 1 second at first. Bop, bop. Okay, that was 1 second, minus 1 second. There we have it. Okay, that's a funny curve. It goes down to 0 and then stays at 0. Okay, maybe let's look at the beginning. You can also do that here. 0 or 1, it starts with 1, 100. That's just the x-axis. Okay, now I see something interesting, right? It's going down like this. So it's going down pretty quickly. What does it mean? You have a few very frequent words, and then it gets less frequent very quickly, and then you have a long tail of words which are pretty infrequent. So if I go further down, there are words which occur 2 times, 1 time, maybe only. A lot of words which only occur once. And this law is called Zipf's law. You will do that for any text. It always looks like this. It's very, unless you do something very strange, and it's a very unnatural text. If it's text in almost any language that is tokenizable in the way we explained, it will look like that. And let's just go back to the slide. So it's a hyperbola, and actually you can, this is the law. It says the frequency is proportional to 1 over n to some exponent. And let's just check that. How do I check that it actually follows that law? And let me just take that and do some little calculation here. So if I do that here, Fn equals to some constant time n to the minus alpha. If I take the log on both sides, so if I do log here, log Fn is log of, and this is now c times n to the minus alpha, and now our first math for this course, log of product is sum of logs, and the minus alpha comes down, so this is minus alpha times log n plus log c. Yeah, and what do we have here? So if I now take this to be my y, and this to be my x, which is what I would do if I have a log-log plot. So this was on my x-axis before, right? N was on the x-axis, 1, 2, 3, and this was on the y-axis. Now I put log of the y-axis and log of the x-axis, and then what I should see is a linear function, right? On a log-log plot, and look up log-log plot if you are not familiar. It's minus alpha, which means a falling line, plus log c, which will not go through the origin. It's also written here. Let's just do this. We can do this in GNU plot by just setting log scale xy. Now I will just have a logarithmic scale on the y-axis and on the x-axis. And now I'm expecting to see like a falling line. And yeah, it's not the straightest line, but it's a line. And I could even read off what? Yeah, let's show the full data, exactly. Let's maybe first show, and now it's party time, so we will have, can you close the door? Let's look at the first 10,000. So initially a little wobbly, but then it's pretty amazing, right? It's like almost perfectly straight line here. That's Zipf's law, and it's just a collection of text, right? And you take any other text, it will also look like this. Let's look at the whole thing. let's just remove that here. And then we will see that it's not perfect. So it's here, slide, bend downwards. Now here it's, there are so many words which are, there's a discretization thing here, right? At a certain point, words occur only once or not at all, so it's not continuous. But it's a straight line. The slope goes down because the exponent is minus, and you can even, if you just do linear regression here, draw a line through it, you can even read off the C and the alpha. So that's Zipf's law. We should see a falling line, and we saw that. Okay, any questions about... So now we have written our first program. You have learned something about inverted lists and about Zipf's law. Any questions about this so far? Last 10 minutes are about the course systems. Any questions about this? Yes?
Does the program, the way you wrote it now, disregard umlauts?
Yeah, the program disregards umlauts. That's absolutely correct. We made it very simple here. We just said words are maximal sequence of this, but we could add them here if we wanted.
So if we have, for example, a director and the name has an umlaut, then that would just get dropped.
Exactly. It's yes, exactly, that will happen. So let me go back to the slides with the funny... So with what we just did, this would become one word, and this would become... It would be split here, it would be gem, and then zipper, and which is not what you want, but for the exercise sheet it's fine because the texts are pretty simple. And this is hard to do right in general, but yes?
A small note.
Mm-hmm.
If we want to adopt Python 3.13, you have to change on the re.split. You have to explicitly write the max split equal instead of just the number.
So if you use Python 13, then you have to do what here? In which line, Robin? 36? Yes?
You have to write before the 2, you have to write max split equals 2.
Oh yeah, so that's, Python likes to break everything. So if you use Python version 13 onwards, the syntax is a little bit different. Max split equals 2. But you will figure it out. Any question about inverted index? And maybe that's time to go through to the exercise sheet real quick. Here, if I find it, which I might not. Okay, we have everything is... there it is, exercise sheet. So, that's the exercise sheet. You just take what I've written, and you can just take whatever we write in the lecture, you can take and extend from there. And now, one thing you should fix is, and there's a hidden pitfall here, pay attention, I'm telling you. This should still run in linear time, and if you don't pay attention, it doesn't. So, I ignored, that if it occurs multiple times, it will be appended multiple times. We don't want that for the exercise sheet, and you have to pay attention. Then you have to write the intersect function. I didn't write I didn't do any keyword search here. I just computed the inverted index. And then you should write a function that just takes a keyword query, looks up the inverted list, intersects them, gives you the result, and then you should just write a little function that you type something in an infinite loop, and then it just outputs the top 3 movies matching your keyword query. So that's like you're effectively writing a little search engine. And then there's a lot of optional stuff you can do, like in all the exercise sheets. If this is too easy for you, if you are very familiar with Python and a lot of practice, then maybe you want to do more stuff, nicer algorithms for intersection, highlight the query words, and so on. And then here's another exercise, so play around with it, find some queries which work well, and also find some queries which don't work well. We have already seen an example. If you type Spielberg, you would expect movies by Steven Spielberg, but actually you get a movie which says this is not by Steven Spielberg. It was set to be directed by him, but then wasn't. So just try to find some of these pitfalls. And then you submit this to our system. We're using SVN, which is like a older version of Git, much simpler, should be simple enough. There is on our, let me just do that. And now there's something to ask here. We have a tutorial here, right? Yeah, it's here. You can find a link to a video tutorial how to use our course systems. And we might also have a session later this week, half an hour. I will talk about that in a second, where you can just come and ask questions. So yeah, it's just a versioning system. You submit it. Everybody has a folder there. Name of the folder is just your Uni account. And there you just create a subfolder, sheet -01. And it should really be called lowercase sheet -01. Lot of opportunities to make mistakes. Capital S, underscore, no zero. It will not work then. You have a question? On the?
About the first exercise.
First exercise, yes.
There's this intersection function which we should write. You just mentioned before that we should use like this algorithm which you just presented.
Yes.
Is it advisable to just use like the built-in Python set functionality for that?
Oh yeah, you shouldn't use the, of course there are functions in Python for everything. Maybe in Python there's also a function for building an inverted index. I'm sure somebody has written a package, you should not use that. I mean, the point of the exercises is that you do the stuff yourself. So if Python has a function for intersecting two sorted lists of integers, which I'm sure it has in some package, you should not use it, obviously. Yeah, and even if it's part of the defaults, you should not use it. So the point is. And also, you will see that, that's actually the hidden pitfall here. Using Python functions is dangerous because you read the documentation, you see what it does, but maybe you're not sure how it does it. And maybe it will do it inefficiently, and you want to do things efficiently. So you should not use the functions which are doing what the exercise is asking you to do. But good question. Okay, that's the exercise sheet. Let me go back to this again. Yeah. And then please always add this file, experiences MD, so that's Markdown, where you just write. You can also do that if you don't do the exercise sheet, just for every lecture, commit a file where you briefly say, did you understand everything? Were there some problems? Was it hard, easy? Anything you want to tell us, that's really useful for us to get feedback after each lecture. How was the lecture for you? How was the sheet for you? So that we can fine-tune. Okay, and now, this is just for reference. So there is Daphne, our course management system. Let me very quickly show it to you. That's here, you can log in. Let me quickly log in here with test user. You log in with your Uni account. So yeah, this test user is already subscribed to a lot of past courses. Now I think I want to subscribe to this course, so you can just do the same thing in case you haven't. Let me just take my email address here. Auto completion doesn't work. So you just sign up. Oh wow, there's the category for me now. Oh, and there's even a drop down. Wow. But there's no category for me here. None here. So, register. Now I'm registered. And now we have, so then you will see information here. And now, will I get, do I see my SVN here, Robin? So you should now have a directory in our repository system here, and I wonder where I see it. So you have a link to the forum here. Okay, why do I have to? I'm surprised. So there are some snags here. Not sure, you shouldn't. You should be automatically subscribed to the forum. And now I'm not found. Maybe it's because I'm the test user. Anyway, so if you register to the system, You should find there your tutor, your points, link to the forum, link to the and there's a video about this. I will not explain it here because it's boring for some, and you can watch the video yourself. Jenkins, it shouldn't be called Jenkins, it's our... Let me just briefly say what's there in principle. There's a forum for asking questions. I think you already saw that because we used it for just the list of who gets to attend in the first course. There are guidelines for asking questions on the forum. This is just for reference here. Subversion is where you will submit stuff, where you also will get stuff. So everything we do here, the exercise sheet, the slides, are in Subversion do. So you just do update, you get the latest material from us, you do commit, you give us your latest material. There's instructions on the web page. I will not go through it here. And this is something what we have done now. I've run the code, checked, ran through the doc tests, see if they work. This is done automatically by our system. You will see it. As soon as you upload something, it will run automatically, see if the tests go through, and then you either get sunshine or rain. Yeah, and I will not show this now. And the question is who, so we are at the end, who would like, so there are instructions on this on the web page, and there are also videos on this. Here's a video, there are instructions. Who thinks they would like a session, half an hour, where I can do this together with Robin and ask questions? Who feels that they would benefit from that? Then we can organize that. If nobody shows hands, we will just not do it. That's also fine. Maybe you just want to read the instructions and ask questions. Is there anybody here who says, yes, please, live session for me, where somebody shows this? I don't see any hands, also not on Zoom. Robin, you want it?
Maybe try it next week. Maybe try to program it, because I don't know where I can handle this concept.
Okay. So if there are just individual people, then we can make individual appointments. So let's do it that way, because I saw probably some of you are also still shy. So I don't see a lot of people wanting this. If they're individual people, you can just tell us, and we can make an individual appointment and help you. And the others might just figure it out from the material on the slides here. Tutorial for Mac users. Yeah, always the Mac users. If you use a Mac, you're a bit on your own. I mean, things should work, but there are always some idiosyncrasies of Mac. Yeah. Just try it. So, yeah, Windows has subsystem Linux for a long time now. It should work, but yeah, Mac, same. Mac has Linux inside or is based on a Unix-like system. Try it. We try to help. We can't promise anything. Any questions for now? That was the first lecture. You know what the exercise sheet is. Here are some references in the end. You don't need them, just if you're interested. Any questions for now? Okay, then that's it for today. Have fun and see you next week. Bye-bye.